It's hard to explain why a creature with a mischievous grin and sharp teeth has captured millions of fans worldwide. Labubu isn't a movie character or a game mascot, yet collectors line up overnight just to buy one box. Each figure goes through dozens of precise production steps before it's complete. So what makes this tiny toy so powerful that it sold out faster than the latest smartphone? Labubu was created in 2015 by Hong Kong artist Ka-Sing Leung, a designer known for his surreal, slightly eerie characters. What began as a sketch turned into a figure produced by Pop Mart, the Chinese toy company behind Asia's designer toy boom. Labubu's expression, a smile somewhere between cute and sinister, became its signature. In a few short years, the toy moved from underground art fairs to mass-market stores. Limited editions and blind box releases made every drop unpredictable, driving global demand. Each batch often sells out within minutes, with collectors trading figures online at several times the retail price. Yet behind the hype lies a detailed manufacturing process that mixes industrial precision with handcrafted art. Production begins with liquid resin and PVC granules stored in sealed drums. Each batch is tested for density and color consistency before entering the casting hall. Here, automated mixers combine pigments and plasticizers to achieve the right flexibility and tone. The resin is then vacuum poured into silicone molds that capture every curve of the sculpted prototype. Inside a temperature-controlled chamber, the molds rotate slowly while heating coils maintain about 60 degrees Celsius. This movement spreads the resin evenly, preventing air bubbles from forming inside the thin walls. After cooling for 20 minutes, workers remove the hardened parts and trim excess material with precision blades. Every piece, head, body, ears, and accessories, is weighed to ensure uniform thickness. Defective casts are melted down and reused to reduce waste to under 3% per cycle. Once molded, the raw parts move into the finishing room. Rotating tumblers lined with soft beads polish away fine dust and casting residue. Compressed air removes particles, while static neutralizers prevent fibers from clinging to the surface. Each piece is inspected under white light for seams or micro scratches. If needed, operators use handheld grinders to smooth out joints before painting. Even though Labubu is a small toy, the surface finish has to feel uniform, matte but not rough. A pre-paint cleaning tunnel sprays warm deionized water to wash off residue. After drying, the figures are ready for one of the most demanding stages: paint application. Painting combines automation with artistry. Robotic sprayers apply base colors in multiple passes: primer, main coat, and matte seal. Each layer cures under infrared lamps at 50 degrees Celsius to prevent color distortion. For special editions, human artists take over. Using fine brushes and airbrush guns, they add subtle gradients, teeth highlights, and the distinctive eyes. A single artisan can finish about 120 heads per hour, far slower than machines but more expressive. Ultraviolet lamps harden the paint instantly, locking colors permanently into the resin. Vision scanners confirm alignment of facial features and reject any print that falls outside 0.2 mm tolerance. Once complete, every figure receives a clear protective coating that resists scratches during assembly. Which part of this process impressed you more, the hand painting or the precision molding? Drop your answer in the comments. Different production lines handle different character variants. Arms, legs, and accessories arrive on synchronized conveyors. Mechanical presses attach joints using calibrated torque, so the limbs can move smoothly without loosening. Technicians test each connection manually to ensure the parts rotate evenly. A robot then inserts the head onto the body with a quick downward motion. For versions with transparent components, workers wear gloves to prevent fingerprints. Each figure then moves to a balance test platform. Sensors check that it can stand upright without toppling. Even a 1-degree tilt can fail inspection. Only balanced figures continue. Others are adjusted or reassembled. Final inspection happens in a brightly lit hall. Cameras photograph every figure from multiple angles, comparing color and dimensions to a digital master. Any mismatch triggers a red light for human review. Approved figures go to the packaging area, where automatic dispensers prepare the iconic blind boxes. Each box hides a random figure sealed inside a foil pouch to prevent tampering. The packaging machines weigh every unit. Even a 1-gram difference can reveal a missing accessory. Labels are printed with series name, production code, and authenticity mark. Boxes are stacked in batches of 144 and shrink-wrapped for export. The entire journey, from raw resin to retail box, takes about 6 hours. Before Labubu took over display shelves, another toy ruled childhood for generations. No matter where you grew up, chances are you had one. A soft teddy bear tucked beside your pillow, worn from years of hugs. But behind that gentle smile lies a complex manufacturing process that turns synthetic fur and cotton into a symbol of comfort. Ever wondered how a simple toy became one of the most recognizable faces of childhood? The teddy bear's story began in 1902, when a newspaper cartoon showed President Theodore Roosevelt refusing to shoot a captured bear on a hunting trip in Mississippi. That single image inspired toy makers on both sides of the Atlantic. In Germany, the Steiff company designed a jointed plush bear. At the same time in the United States, Ideal Toy Company produced a similar version and named it Teddy after Roosevelt. By 1907, millions of stuffed bears were being sold in Europe and America. Factories grew around a single idea, that comfort could be sewn, stuffed, and shared. Over the next century, the teddy bear evolved from handmade cloth to mass-produced plush, from children's toys to collectibles. Today, global production exceeds 40 million units a year, with styles ranging from basic play bears to luxury designer editions. Every teddy bear starts as rolls of synthetic fur, a blend of polyester fibers woven onto soft backing cloth. Each roll can stretch up to 50 meters and comes in dozens of shades, from caramel to snow white. Before cutting, workers brush the fur to align the nap direction, ensuring every panel looks consistent after stitching. Automated cutters scan digital templates and slice the fabric into pieces for the head, body, limbs, and ears. Laser beams mark seam lines to guide sewing machines later. Waste fabric is vacuumed into recycling bins and reused for smaller accessories. In a single hour, one cutting table can prepare enough material for 600 bears. Next, the cut panels move into stitching lines. Here, high-speed sewing machines piece together the outer shell with reinforced seams. Operators alternate between machines and manual stitching to shape curved areas like the head and snout. Precision is key. Even a 2mm deviation can distort the bear's expression. Once the pieces are joined, they're turned right side out and brushed again to restore the fur texture. The fabric shells are checked for loose threads or skipped stitches before filling. In modern factories, one stitching line of 6 workers can produce more than 1,000 bear shells per day. This stage gives each teddy bear its volume. Hollow bodies are placed under pneumatic fillers that blow fine polyester fiber into the cavity. Operators control air pressure and fill time to match the target weight listed for each model. Too much filling makes joints stiff. Too little leaves the bear floppy. After the first fill, bears pass through shaping tables where workers tap, pat, and compress the fiber evenly by hand. Shoulders, arms, and legs are filled separately to create even balance. Some factories use ultrasonic sensors to verify internal density, ensuring every bear feels the same when hugged. When satisfied, the final opening is stitched closed using concealed seams. Before moving on, inspectors squeeze and flex random samples to test resilience. Each bear must spring back instantly to its original shape. Now the bear gets its personality. Computer-controlled embroidery machines sew eyes, nose, and mouth with thick polyester thread. Each stitch is mapped in digital coordinates accurate to 0.1 millimeter. The process takes about 30 seconds per face, followed by a quick trim to remove excess thread. Some models receive plastic eyes that snap securely into sockets from the inside. Safety regulations require that every attachment withstand a pull force of at least 90 newtons, strong enough to prevent detachment during play. Once finished, the bears travel through brushing tunnels that clean fur fibers and remove loose lint. A short steam bath at 70 degrees Celsius sanitizes the surface and restores fluffiness. By the time they leave this stage, each teddy bear has a consistent look, calm, symmetrical, and soft to the touch. Everyone remembers their first teddy bear. Do you still have yours? Share your memory in the comments below. Completed bears arrive at inspection stations lined with bright lights. Workers check stitching lines, symmetry, and fabric tone under neutral color panels. Weight sensors verify that the internal filling matches the model specification. Bears are then brushed one last time before entering packaging. Depending on brand, they may be placed in transparent plastic bags or luxury boxes with printed inserts. Automated scales flag any box outside tolerance. Even 1 gram off can signal a missing accessory. For export orders, cartons are sealed and wrapped in vacuum packs to reduce shipping volume. Temperature-controlled containers keep humidity low to protect the fibers. In total, a modern factory can complete a standard bear from fabric to box in just under 3 hours. Plush and stitches fade into the past. Now the factory floor is filled with vinyl, color. More than 200 million Funko Pop figures have been sold around the world. Each one is instantly recognizable. Big head, small body, and unblinking eyes. Inside the factory, their faces are printed like phone components, not painted by hand. What started as a niche vinyl figure now defines modern pop culture. But why do people keep collecting them? Funko began in 1998 in Everett, Washington, making bobbleheads of retro mascots. When founder Mike Becker sold the company, its new owners looked for a new direction. By 2010, the answer appeared, a blank-faced vinyl figure with a massive head and minimalist charm. The Pop Vinyl series hit stores and instantly took over pop culture. The idea was clever: simple molds, flexible designs, and licensing that spanned from sports icons to superheroes. Fans started collecting not just characters, but variants. Metallic, glow-in-the-dark, flocked. Conventions sold exclusives that disappeared within hours. What looked like a toy became a system of design, production, and fandom operating at industrial scale. Production begins long before any plastic is melted. Design teams sculpt each character digitally in 3D, setting exact head-to-body proportions. Once approved, the model moves to a CNC mill that carves steel blocks into molds. Each mold contains multiple cavities, so several figures can form at once. Technicians polish the metal surface to a mirror finish. Temperature sensors and cooling channels are added to maintain uniform conditions during molding. Before the line starts, test shots confirm every detail, from the curve of the chin to the edge of the eye socket. Pellets of soft PVC enter the injection press through large hoppers. Heaters liquefy the material at more than 180 degrees Celsius, turning it into a dense flow of molten vinyl. The press forces the liquid into the mold at extremely high pressure. In a few seconds, cooling water solidifies the figure. Mechanical arms open the mold and extract newly formed heads and torsos, still warm and flexible. Automated cutters remove excess flash. Suction lines pull trimmed bits into recycling bins. These clean, featureless forms, often called blanks, are the foundation for every pop figure, no matter the character. Each blank cools for several minutes before inspection. Technicians measure wall thickness and surface quality. Anything warped or uneven is ground down and reused. Once cooled, rows of blanks move into a dust-free paint booth. Here, color gives them life. Robotic sprayers sweep across the line, applying primer, base coat, and matte finish in timed intervals. The paint sticks through electrostatic charge, wrapping the curved surfaces evenly. Infrared heaters cure the pigment quickly without softening the vinyl underneath. For complex characters, one automated line can finish over 12,000 pieces in a single shift. Limited or special edition figures still go through partial hand painting. Workers add gradients or metallic tones using fine brushes under magnifying lenses. Optical scanners check hue consistency against a digital color reference. This stage defines what fans recognize first: the face. Pad printers, similar to those used for electronics, stamp black ink onto the head surface. Every pass lays down a single shape: left eye, right eye, eyebrows, or mouth. Laser markers align each figure before contact, keeping the offset under 0.05 millimeter. For glow variants, special ink mixed with phosphorescent powder replaces standard pigment. UV lamps flash instantly to harden the print. Between stations, air curtains prevent dust or smudging. Each figure passes through a tunnel of cameras that capture multiple angles. AI software compares the print to a master pattern, flagging any deviation in gloss or position. Rejected pieces return for cleaning and reprint. Nothing proceeds unchecked. When heads and bodies meet, a friction joint locks them together. Some models include bobble springs, installed with mechanical presses. Accessories like helmets, glasses, or capes attach next, each glued by micro-dispensers calibrated to milligrams. Finished figures roll onto vibration platforms to ensure no part comes loose. Those that pass continue to packaging. Boxes are printed, cut, and folded on site, each showing artwork, collector number, and barcode. Transparent PET windows are inserted automatically before the figure slides inside. The design of the packaging itself changed how people collected. Fans could display figures without opening the box. Every sealed carton receives an RFID tag for batch tracking and authenticity. From there, robots stack and wrap pallets bound for global distributors. A single facility can produce nearly 60,000 Funko Pops in one workday, identical in shape, paint, and proportion. Which Pop figure started your collection? Share it below. We'll feature some of your answers in the next video. Next up, a collectible shaped like a bear, built with the precision of a machine. A single Bearbrick stands only 7 centimeters tall, yet some are coated in real gold or platinum. Every surface, curve, and joint is engineered with millimeter precision using the same machines that mold automotive parts. Collectors treat them as art, not toys. Each series produced in limited runs that vanish in hours. How does industrial plastic turn into an object displayed in museums and luxury boutiques? Bearbrick was launched in 2001 by the Japanese company Medicom Toy. The concept was simple: take a basic bear silhouette, split it into 9 jointed parts, and treat it as a blank canvas. Artists and fashion houses turned that shape into limited edition works. From Chanel and Nike to Andy Warhol's estate, the figures became a collision point between pop culture and modern design. Instead of mass-produced toys, they were released in short runs called series, often tied to art exhibitions or collaborations. Some versions now sell for thousands of dollars at auction. Yet behind the exclusivity lies an industrial process as exact as any in high-tech manufacturing. Bearbricks are made from ABS plastic, the same durable polymer used in electronics casings. Pellets arrive in sealed drums to prevent dust and moisture. Before molding, they're dried at 80 degrees Celsius to stabilize viscosity. Each batch is tinted with precise pigment ratios measured in grams. The color mixture is fed into injection machines that heat the resin to 230 degrees Celsius until it flows like syrup. Under pressure exceeding 1,200 bar, the liquid plastic fills the metal molds in less than a second. Molds are fitted with multiple cooling lines to harden the material evenly. Once opened, robotic arms lift the pieces, head, torso, arms, and legs, onto trays. Any excess is clipped off automatically, and scrap returns to the melting tank for reuse. Nothing leaves this stage with more than a 0.2 millimeter variance from specification. Rough edges are smoothed in tumblers lined with fine resin beads. This polishing step gives the surface a uniform matte finish, ready for paint. Next, air showers remove static particles that could trap dust under coating. Each piece passes through a plasma treatment tunnel, which increases surface energy and improves paint adhesion. It's the same technique used in phone manufacturing. Afterward, robotic sprayers apply a thin primer layer that dries under infrared lamps within minutes. Precision scanners verify smoothness by reflecting laser beams across the surface. If any scratches or pits are detected, the part is automatically pulled for rework. Bearbrick's artistic identity begins here. For standard designs, pad printers transfer artwork from etched plates directly onto curved surfaces. Each pass applies one color, building the image layer by layer. Alignment is controlled by optical sensors accurate to 0.03 millimeter. Complex editions like camouflage or metallic gradients use hydro dipping. Printed film floats on a warm water surface while the part slowly submerges through it. The pattern wraps around every contour without distortion. After printing, the pieces move into drying chambers set at 60 degrees Celsius for consistent curing. Some designer editions receive additional hand-painted touches, metallic strokes, airbrushed fades, or embossed logos. To preserve detail, protective clear coat is applied in 2 layers and cured under UV light. Unlike ordinary figures, Bearbricks are built from precisely engineered components. Each piece clicks together using ball and socket joints molded within a tolerance of 0.05 millimeter. Robotic arms handle the assembly sequence. Legs first, torso next, arms, and finally the head. Torque sensors monitor resistance at every joint to ensure smooth rotation. If any movement feels too tight or too loose, once assembled, every figure undergoes a drop test from 1 meter to confirm joint durability. The engineering may look invisible, but it's what makes each bear pose without tools or screws. Before packaging, figures line up under bright white light for final inspection. Operators check surface gloss, print clarity, and color alignment. Even a faint blemish can send a unit back for repainting. Accepted figures move to labeling stations, where serial numbers and edition marks are printed on the back. Boxes are matched to specific size scales, from 100% to 400% and even 1000% display models. Each box is designed for visibility, transparent windows, minimal graphics, and a code identifying its collaboration series. Collector sets receive authentication cards and protective sleeves. Finished cartons are shrink-wrapped, scanned, and logged into an internal registry before shipping. Inside Medicom's distribution centers, climate-controlled storage keeps the temperature steady to preserve coating quality. Have you ever seen a Bearbrick collaboration that surprised you? Tell us in the comments. We'll feature the most creative ones in a future video. From resin figures to stitched fur, from pop icons to designer bears, every creation we've seen today began as raw material and ended as a piece of human imagination. Labubu showed how art can live inside industrial precision. The teddy bear reminded us that softness and comfort are engineered as carefully as any machine part. Funko Pop turned production lines into pop culture history. And Bearbrick proved that a simple shape could become a modern symbol of art and design. Behind every toy lies chemistry, motion, and measurement, all working together to shape emotion into something you can hold. These objects may seem small, but each carries the fingerprint of an era, a craft, and a culture that never stops evolving. If you enjoy discovering how the familiar is made extraordinary, don't forget to subscribe. Join Captain Discovery again as we explore the next factory where imagination takes form.